Then you might ask, well, how highly correlated do they have to be before they're the same thing? Or how uncorrelated do they have to be before they're different things? And actually the answer to that comes down to something like practical utility. It's like, imagine I'm trying to figure out how well you'll do in university. And I measure one thing, and it's correlated at 0.7 with another thing I measure about you. Then I might say, well, are those two things the same or different? They're pretty highly correlated. You're high in one, it means you're going to be high in the other. Well, so is there any utility in measuring both things? And the way you figure that out actually is you do it statistically. So we take the target, which might be your performance across university. And then we say, well, can we predict your performance across university better by using one variable or two variables? So we would enter them both into a regression equation. All a regression equation does, it's quite simple. So you're trying to predict a target, and the regression equation tells you how well you can predict that target if you know another fact. Now then it gets a little complicated because that's a correlation. How well you can predict B with A. Well, a regression will say how much you can predict C if you know A and B, or A and B and C and D and E, because you can use multiple predictors, and you can weight them. So it might be 2 times A plus 1 times B equals C. And that's all a regression equation does. It's just multiplication and addition. Very, very straightforward. And so two variables are sufficiently different functionally if you can use both of them simultaneously to predict something of interest. So again, it's a tool-like approach. This is how the psychometricians do it. Is something real? Well, it's real if you can measure it and it helps you predict. That's how it's defined. So then you might say, well, are there these multiple intelligences? Well, the first question would be, well, what do you mean by are there? And the answer to that would be, well, let's specify the question. Since we're going to be scientific about it, let's predict how well people do in university. We'll start with the assumption that if intelligence isn't associated with university success, then you're probably not talking about intelligence. Now you could argue that, right? Because you could say, well, intelligence has nothing to do with university success. But that's a definitional matter. We'd have to agree to begin with. Is it reasonable to start with the presupposition that intelligence and university success share something in common? Well, I think you have to be daft to deny that initial proposition, although you could. Because you could say it was privilege or socioeconomic status or any number of sociological phenomena, and some of those are obviously relevant. Social class, for example. Because, you know, if you're in a higher social class, and all things being equal, intelligence included, if you're in a higher social class, you're more likely to go to university than you are if you're in a lower social class. So there's other factors that are going to influence whether or not you do well in university, but we're going to assume that one of them might be intelligence. Well, then you would ask, well, if you measured social intelligence, so that's, what do they call that? Social intelligence? No, emotional intelligence, which does not exist, by the way. Emotional intelligence, moral intelligence, linguistic, musical, logical, mathematical, spatial, body kinesthetic, interpersonal, and interpersonal. All different forms of intelligence. Okay, so to answer the question of whether they exist, what you do first is pick a target, prediction of university performance. Then you make a measure for each of them. Then you test to see if the measure measured the same thing across multiple instances within the same person. That's a reliability test, because what the hell good is your ruler if it stretches when you use it? It has to measure the same thing multiple times. And then you would say, okay, we'll take all these different intelligences measured the way we've decided to measure them. The first thing we'll do is see how highly correlated they are, because if they're two of them are completely correlated, then you have one, you don't have two, because that's virtually the definition of one instead of two. You can factor analyze them and see if you can pull out what's common across all of them. That's another thing, because then you might say, well, intelligence is what's common across all the measures of these intelligences. It's a proposition, it's not a fact. You have to decide if you're going to agree with it. But that, if you were going to do that, you'd use a factor analysis. You'd say, well, if someone was more likely to be musical, if they were also high in linguistic ability, and more likely to be logical and mathematically inclined if they had high spatial ability, etc., then you'd be hypothesizing that there was one factor behind all of those manifestations that's somehow similar. And maybe there wouldn't be. And then you'd take all your measures and you'd put them in something like a multiple regression analysis, and you'd predict your target, university performance. And then maybe you'd say, well, wait a minute, let's not just use university performance. Let's use junior high performance, high school performance, university performance, and job success. And then let's say that the only things that predict success across all of those categories and that are the same we're going to define as intelligence. Well, that's basically how you end up with IQ. You could say that IQ is what's common across all possible sets of intelligence tests. Now, people are going to debate that because you still have to define what constitutes a test. But the way the psychometricians have managed it and have taken care of this, at least to some degree, is to say, well, we're not going to define everything that we measure as intelligence. So extroverted people are more socially fluent. Are we going to call that intelligence? No. We're going to call that personality. We're going to call that extroversion. And we're going to call stress tolerance. You could say, well, if you can tolerate more stress, you're more intelligent. It's like, well, no, that isn't how we've defined it. We're going to define that as being lower in neuroticism. If you're cooperative, you're more intelligent. That's emotional intelligence. Well, what? You're less intelligent if you're competitive? Well, no. So we've parsed that off to agreeableness. So then the question might be, is there anything left of these so-called intelligences once you control for personality and IQ? And the answer is no. Nothing. Nothing left of them. And the people who keep pushing these ideas keep trying to push them because they don't like the idea of real individual differences. And to me, that's just a matter of sticking your damn head in the sand, because it's obvious. Here, you're going to have a child. You want the child to have an IQ of 65 or 145. Decide. Okay, so you're all going to vote. Okay, you think any one of you is going to vote to have a child with an IQ of 65. That child's going to have a hard time developing even linguistic ability. They're never going to learn to read, right? They're never going to leave home, in all likelihood. So which child are you going to pick? Well, so do you believe in intelligence or not? Well, obviously, if you have any sense.